Good morning. Well, I'm a biologist, so again, we don't have many geologists this morning, but I'm going to give you a bit of a talk on reclamation. I've called this an innovative practice. Is it innovation? I'm not sure. It's a change. I should talk to Carl sometime. I'm not sure where this falls within the definition, but it's an improvement, I think, over what is currently happening, so I think that is somewhat innovation. In tailings management, if you want innovation, you'd get away from tailings altogether and have no tailings on the surface. But as long as we have tailings, my role in this is trying to make those tailings a more productive material. Because at the end of the day, when the mining company disappears and all the infrastructure is gone, those tailings remain as the scar on the land. And while a lot of work has been done to revegetate them, in most cases, it's not really a productive land use, and I think there's opportunities there to advance that side. So I am going to just talk about a few things, just talk a little bit about conventional tailings reclamation from my perspective. It's not a global perspective, it's my perspective, and it's mostly based in Ontario. Most of the stuff that I've worked on has been in Northern Ontario, so I'm kind of geared on that side of it. And talk a little bit about organic residuals. You know, every municipality out there is trying to divert organic residuals from landfill. And I think the challenge for that industry is trying to create a sustainable outlet for those materials. And then I'm just going to talk about the potential to get bioenergy crops on tailings and some of the benefits that may bring. So if I just do a very general background on tailings reclamation, if you kind of go back to the 50s or 60s, and these are very loose time frames, I'm not... these are certainly not written in stone. There was just, we developed a basic understanding of what the critical deficiencies were within tailings, what the chemical constraints were, what the nutrient deficiencies were, and basically it was an extension of agricultural practices. So they addressed the acidity by adding lime, lots and lots of fertilizer typically. In many cases, because of the sulfides, you'd have to go back and re-lime, re-fertilize, adding seeds, obviously, introducing mulch, and then developing the practice of hydroseeding to get at some of these areas. And basically out of that, simple grass covers were established. I'll point over to this one maybe for a change. Simple grass covers established, which basically just controlled dust. And at the time, I think the general feeling was, for a mining engineer looking at that, said it's green, perfect, we don't need to do anything more with the tailings. As that kind of moved along, you notice that successional species were invading. Mining companies started developing tree planting programs. We started to recognize that acid mine drainage was having quite a large impact. And basically the thinking at that time was that a vegetative cover would limit or prevent actually acid mine drainage, which we all know is not actually at all true. And as we moved on, a lot of focus over time, was put onto acid mine drainage, and rightly so. These are large environmental impacts, and focuses on things on how do we control acid mine drainage, how do we rehabilitate sites that have gone acid, such as this, and much of the research on that has been geared towards engineered covers, in this case geotechnical liners, but cleaning up those kind of messes, looking at water covers, wetlands, another different land use for that, so it's aesthetically much better while helping to control acid mine drainage. And then also there was a lot of thought put into how to contour these tailings rather than just being in a heap at the bottom of a valley or sort of a scar on the land, trying to merge those back into the surrounding environments of the topography. And it's an example of coal spoils that have been tailored into the side of the hill or the mountains in British Columbia and trying to mimic what was there before and the landform that was there before. So that's kind of the way things evolved, and I don't think things have really gone beyond that very far. Certainly acid mine drainage is the biggest concern, but in terms of, at the end of the day, when you're left with a tailings pond, there's not been a lot of thought put into whether you can make a more productive land use out of that. So my background, I got started in looking at paper mill biosolids actually in Elliott Lake. This is the Pronto mine. This was a copper tailings site. It was actually uranium, but then overlain by 2 meters of copper tailings. Mining company spent lots of effort trying to rehabilitate the site through lime fertilizer, and was unable to do so. And actually right out of my master's, I got a contract to work on this. And so we did some work on trying to figure out what we can do. Acid mine drainage wasn't a concern here because this company has a treatment plant there, and their closure plan is to operate that treatment plant in perpetuity. They were interested in dust control and erosion control on those tailings, and how do we solidify those and get a good vegetative cover on there. This area is basically characterized, the Canadian Shield, as not having a lot of overburden, so there wasn't a lot of materials there to use as a cover. And so we started looking at industrial wastes and settled on paper mill biosolids, which were close by. Long story short, we put about 40 centimeters of paper mill biosolids on. This is around the year 2000. And then if you go 2008 is the last time I was there. We've now got a good vegetative cover on there with 20 or 30 foot trembling aspen trees coming in, and you can barely tell that that's actually a tailings pond. By the mining company's estimate, they saved them about $2 million because their next best option was to quarry all the rock around the area and use that as a cover, albeit a very nutrient poor cover. So they were happy with that. The paper mill biosolids were being landfilled at a municipal landfill, so the tipping fees paid for that material to be brought to site, and the mining company reimbursed the paper company half of those costs, so both companies ended up saving money. So this was actually one of the first sites, I think the first site in Ontario, that did a full-scale reclamation with paper mill biosolids. From there, we started looking at other sites. This is Valley in Sudbury, Coppercliff. Drainage areas, which were constantly being eroded, exposing fresh tailings, generating the acid from that. Again, lime fertilizer, they couldn't get things established there. We applied simply about 10 centimeters of paper mill biosolids, lined that. So you can see the site in, oops, I did it now. See the site in 1999, and then again in 2000, that's the drainage ditch right through there with the banks on either side. And again, it's only about 10 centimeters of paper mill biosolids. Those paper mill biosolids were landfilled on, at the paper mill itself. So again, we're using one waste to reclaim another waste and trying to demonstrate that there's an opportunity to use these kind of materials. Based on that kind of work, Goldcorp up in Timmins were able to secure a 5-year contract with Abitibi Consolidated to take all of their paper mill biosolids for that 5-year period to reclaim some of their mines. This is an example of a site they inherited on another purchase, but they did the cleanup on this, and while lots of engineering went into dam reconstruction and grading and all that, the final growth medium here was those paper mill biosolids, and it's worked very, very, very well, and again, diverted that material from landfill. Municipal biosolids have typically been shunned by mining companies, initially because of the concern over metal content in there, which is kind of funny that you're afraid to put something with high metals onto a tailings pond. But even now, I think for me, the biggest concern is actually pharmaceutical products that are getting into these systems. Metals have actually come down in those materials substantially with the advent of plastic plumbing and moving away from copper plumbing. But I think the influx of a lot of pharmaceutical use is still an issue for that, but it's being used. This is an example in British Columbia of Metro Vancouver ships their material to Highland Valley Copper, and at no cost to the mining company, by the way, and actually spread that material and are using that for reclamation purposes. So there were some precedents for getting biosolids established or used, and we were trying to take this to another level and get a wider scale use of this. Just quickly, some of the benefits of these materials. One, you're diverting from landfill, which is something I like very much. You can use it very easily for dust suppression. It's a very good growth substrate. It helps decrease metal mobility through the interaction with the carbon and the metals in the tailings. We're using one waste to reclaim another, so good optics from that side. There's potential at some point to develop carbon credits for the mining companies. The growth, you get much better growth typically when you use those materials in reclamation, so biodiversity is typically a lot higher. And hopefully at the end of the day, we can create some sort of a productive land use, which I call Agri-energy. So we got into some discussions with the City of Toronto, and looking at the time they were shipping their garbage to Michigan still. And so we approached them with Valley and Glencore, Inco and Falconbridge at the time, and had some discussions with them about composting their material, taking their material to Sudbury, which is about 3 or 4 hours away, and that we could probably take that material for the next 30 years instead of shipping that garbage to Michigan. And this is the kind of conundrum we got into, where the organic waste suppliers, i.e. at that time the City of Toronto, wouldn't commit anything until the mines actually committed or agreed to taking that material. the mining companies wouldn't commit until the regulators, regulators indicated that they would approve such a use of this material. And the regulators wouldn't approve anything until they had some sort of sound science to say that the impacts were going to be investigated or were investigated. So this is where NRCan came in those discussions, and we decided to form, to try and contribute to this and, develop the Green Mines, Green Energy initiative, which was just meant to be a 3-year field demonstration to try and demonstrate that you can use these materials, that it's feasible, and determine whether we can grow some of these crops. So the goal was basically to try and raise the bar for mine reclamation from establishing forests or what have you. Not that I'm saying there's anything wrong with that, but trying to take it a step further into actually producing something where there's a financial opportunity on those tailings. At the time, the idea for this came from the fact that they were building or planning to build a 20 million litre per year biodiesel facility in Sudbury, and they were looking for feedstock. We have the Valley Tailings, which has about 2,000 hectares of land, which potentially could have supplied a good chunk of that feedstock within 10 kilometers of the proposed build site. Unfortunately, that biodiesel plant, the plans for that fell through, but we went ahead with this program. So I'm just going to highlight some of the findings and what this was about. The scope of the initiative was basically 4 things. What's the impact that the residuals have on the tailings? Can we actually get decent biomass growth on bioenergy crops? The economic feasibility, as well as communication, public education, and tech transfer. So trying to make sure, you may not recall this, but at the time, or shortly before this, there was a proposal for Toronto's garbage to go to the Adams mine in Kirkland Lake in an open pit, an abandoned open pit. And that deal came very, very close to happening, but was basically shut down by public outcry over that. So we were trying to have an approach where we communicated our results, that we weren't shipping garbage, we were shipping a product, which was actually a compost. So that was the scope of that. Primary participants, we had participation from mining, forestry, provincial and federal governments. Laurentian University in Sudbury led the field trials for us. We did do some work with Cape Breton University, by the way, and we had a test site out at Broughton on the coal spoils. Unfortunately, the timelines for Broughton closure changed, and we had to shut that down. But this was a multi-stakeholder project that worked quite well. We had funding from industry. We got funding from the City of Sudbury, which allowed us to go after Green Municipal funds. We had NSERC funding through Laurentian, as well as the Ontario Research Fund, so had several students involved, and it was actually quite a good multi-stakeholder approach. So these are the sites. I'm just going to talk about the first 3 a little bit and just giving you highlights on a few different things. But the Valley site was in Coppercliff, which is just, it was in Sudbury, right in here. And then the other site was Goldcorp in Timmins, and Glencore was basically right between, just north of Sudbury, between Sudbury and Timmins. So the Valley site was an acidic copper tailings. The Glencore site was similar tailings, but with a desulfurized slimes layer on top. So they were non-reactive or less reactive tailings on top. And then the Goldcorp was an alkaline gold tailing site with arsenic. So we had technical challenges. First of all, how do we get the equipment on there to get this kind of volumes of material? And we were looking initially at a 1 meter cover of this, trying to stop oxygen from getting those tailings, maybe get some sulfate reduction occurring and actually precipitate the metals as sulfides in the tailings. And so we were looking at quite a lot of material going on there. So what we did at Valley was wait till wintertime. We let the tailings freeze a little bit. We plowed the tailings to let them freeze good and solid. Then we could get the equipment right on there, end dump and spread right away. And that worked quite well. At Glencore, they opted to try and do this in the summertime, which was actually worked fine. We had the material hauled up from Toronto. In their case, this was a compost from the Toronto area. Hauled up, used walking bed trucks where the material vibrates and comes out of the truck, and then they used much smaller equipment to spread it, and it has worked quite well as well. Now, mining companies aren't going to become farmers. The whole idea, if this ever comes to fruition, is that they will contract this to local farmers to manage that land or lease that land. So we engaged a local farmer to actually use his equipment on this site. So this is just one of our sites at Valley. This is St. Mary's paper mill biosolids, and cultivating, plowing, and figuring out whether his equipment works well on that site or not, and it, for the most part, did. So this, again, is our first test plot, just giving you an idea what it looks like. We did half-hectare test plots. In this case, it was 3,500 cubic meters. In terms of results, this location, that's the Valley Tailings before the plot, and that's exactly where one of the plots went in. So there's the before. We were actually able to grow corn and canola very well on these sites, on this site, full corn cob production. This was actually, corn doesn't typically grow in Sudbury area. This was a hybrid dwarf variety developed by Agriculture Canada, which matures in 60 days. It did very, very well in the tailings. The only problem is it was kind of a low sugar corn and wasn't really suitable for ethanol production, so we ended up dropping that after a while. But we got full pod production on the canola. This graph is a little bit messy, but it's just showing some of the results of what we got in terms of biomass. Our target was trying to get around 10 tons per hectare dry weight of biomass on these plots. We basically did that. I'm not going to go through the whole thing. You've got biomass content here with different sites. I'm just going to focus on canola at Valley, for example, where we did get that biomass. These numbers on top are the seed yields that we got in this particular year. So we got 3.3 tons per hectare canola seed yield on the tailings growing in paper mill waste. The Ontario agricultural average was 2.2 tons per hectare. So that's pretty good when we're beating the Ontario agricultural average on the tailings. So quite happy with that, and it worked quite well. There's some changes. Valley went on strike one year. We were unable to monitor that year. The project was starting to come to an end. What you're seeing here in this decline in biomass was actually because of weeds. It's one of the things I'm not used to dealing with that obviously farmers deal with a lot, but weed control is absolutely critical in this and was something we weren't really expecting at first. Switchgrass is another example. So instead of having annual crops like corn and canola, where you have to constantly rework the land, switchgrass, once established, will continue to grow. You harvest it, it grows back from the roots. You don't have to keep planting it. The literature says it takes 3 years to establish. It worked very well. I keep pointing to the screen. It worked quite well. Very low production first year. It's picked up a little bit second year, and by the third year, we were up to our 10 tons per hectare target. So just a little bit on the economics of if this works out, and I'm just going to use one example for the canola at Valley, where we generated about 3.2 tons per hectare of seed. What I'm showing here is a profit. I'm not sure if that's the right word or not, but basically it's looking at the sale of those canola seeds that after you subtract the typical costs for farming those crops, mining companies have the potential to generate about $900 per hectare. So if we take a site like Valley, based on that $900 a hectare, they have about 2,000 hectares of tailings. If we look at about 60% of that even, pick that number, just something that might be reasonable, at about 1,300 hectares, they have the potential from the sale of canola seed to generate about $1.2 million in revenue or profit from the tailings, which is something I think is novel. And from that kind of a feedstock, if that was sold to something like that biodiesel plant, could generate about 4.7 million liters of biodiesel per year. So that's kind of what we were trying to get to. We're only at pilot scale still, trying to move that on a larger scale, but this is the sort of thing that we're looking at with that. I threw this in. Sunflowers is something that developed quite accidentally, but mining companies were quite happy with this because you walk down the tailings, you've got a field of sunflowers growing on the tailings. It's aesthetically very pleasing. So we typically, well, you could develop an oil from the sunflower, obviously, but it's not really marketable. And what we would do is line the roads with this, so as you drive into the site, you've got sunflowers looking at you all the time. So the next thing we've moved on to now is willows, another annual crop. These are hybrid willows. They're genetically modified to produce a lot of biomass. Very simple process. You get willow cuttings, you just stick them in the ground, right side up. They will root at the bottom and they will shoot at the top. So this is 2011. This is the first year growth. This is 1 year later. And this is 3 years. So this is just a couple of weeks ago. This is at Valley. These trees are 20 feet tall in 3 years. So the idea of this is instead of harvesting these materials every year and getting, say, 10 tons per hectare of biomass, you harvest every 3 years and you get 30 to 40 tons per hectare. So you decrease your cost in terms of harvesting. They establish very, very rapidly. It stabilizes the tailings. And the very interesting part of this is that we did this both on 1 meter of biosolids and we did it on 15 centimeters of biosolids. On 1 meter of biosolids, we're getting okay growth. But these willows are actually growing in 10 centimeters of biosolids right on top of the tailings. These are pH 2 tailings, We haven't limed them, we haven't done anything, we just put the biosolids down, planted these willows. I thought they were all going to die. I thought every one of them wasn't going to survive. Counterintuitively, they've done the best there. And so it's quite interesting. But quick way to stabilize the tailings. This row is basically the equipment would go down the center, would cut 2 rows of trees. Every time you cut these trees, they coppice, so they produce more stems. So every 3 years, you're going to start getting more and more biomass produced. So this is where we're at now, is looking at that. Carbon sequestration, I just put this down as an example. If you start with barren tailings, I'm not going to spend a lot of time on this, and you put a perennial crop on there, just the root growth that develops within the tailings, and I look at this over say a 6,000 hectare site, there's a potential to produce about 46 million tons of carbon CO2 equivalent reductions out of that. So there's somewhere in the ballpark of 1,200 to 1,000 hectares of tailings in Ontario. So I looked at just taking about half of that. And so that's quite a significant amount of CO2 reduction just by that. And then on top of that, there's a potential to grow these kind of crops like willows, harvest them, and put them into biochar. Biochar is very much a buzzword these days, but basically you take that dry biomass, you go at fairly high temperatures and lack of oxygen, you produce 3 things. A gas that typically is used to fire this process, so it's sort of energy neutral once it's going. Produces a low quality bio oil, which can be upgraded to a biodiesel, but it produces, depending what temperature you make it at, 20 to 35% biochar, excuse me, which is a very stable carbon source. So that is basically charcoal, but it can last in the environment for thousands of years. And there's a potential to grow these crops on the tailings, create a biochar, and put that CO2 basically back into the tailings by adding that biochar back in. So this is something we're looking at now. If I go back to the covers, so one of the things we looked at is wanting to know what's the impact of those covers on the tailings. Those test plots, the first test plots I've showed you, have been there now for about 6 years. So we did some cores through those, through the biosolids and into the tailings, and looking at what's the impact of that. Long story short is, without liming the tailings, we've seen an increase in pH from about 2.5 up to about 4.1. This is microbial activity, and this is in the tailings, not in the organic, the biosolids. Rapid increase in organic activity, in microbe activity. And these 2 photos on the right-hand side show the diversity with the control, the number of bands indicating, thank you very much. The number of bands basically indicate the number of different microbes there. The control, geez, I can't get rid of this. The control, there's only a couple of bands there, but you can see in the tailings below that cover, there's a lot more microbial action and a lot more diversity there, and I think that's something looking at, as the last speaker talked about, what's the diversity going in there and how are those microbes impacting the mineralogy within the tailings, metal release, metal retention, and I think that's an area that can be certainly looked at in the longer term. And I think it's an opportunity to compare that kind of stuff with some of these sites where you've got 40-year-old tailing sites that have been revegetated for 40 years and have now basically a functioning soil in there, and trying to compare what happens there. I think there's a lot of knowledge to be gained from that. So is this stuff being applied? This is the Glencore site. I just wanted to give you a photo of this. Our original half-hectare test plot is right in the corner here. Glencore has adopted this. They are, at their own expense, applying these materials. This is a compost material from Toronto to their tailings site in Onaping. So just to give you an idea, we were half a hectare there. Now they're up to about 5 or 6 hectares. They will have this whole area done within 2 years, they tell me. So they'll be up to about 10 or 15 hectares within 2 years. And they expect to do the whole site within 10 years, which would be 100 hectares. It's not huge. It's not going to change, mining. It's not going to make mining that much more efficient, but if we can get this even 100 hectares here in a production of some sort of fuel, some sort of feedstock that can produce something off it, it's a very beneficial use of that land in the longer term. The interesting thing now is Glencore is also taking the grow bark compost from Toronto, and they are now, Enviro Soil has built a new treatment plant in Sudbury, So they are now have a long-term contract to take their biosolids, and they're looking at manufacturing a soil from the biosolids, both the compost and the biosolids, and putting that into use. So it's a beneficial use of this material that is going a long way, I think, in rehabilitating these tailings. And I think this is a step forward. So general conclusions, the GMG initiative demonstrated it is technically feasible to establish these kind of crops. I think it's possible to convert tailings from strictly a liability to a potential profit-generating facility, which can be left over once mining is gone for community use. So for example, if you can produce biodiesel from a tailing site, you can run city buses off that. A very simple example. And that reclaimed tailings areas can become part of the renewable energy and carbon sequestration strategy for the mining industry. And I think at the end of the day, if you can leave something like this behind where you've got fields of canola growing, it greatly improves the image of mining and the sustainability of mining. And I think that's it. Thank you.